Okay, this video is going to look at two kinds of right triangles that we call special right triangles. These special right triangles have specific angle measurements. They're very common measurements, 45 degree, 30 degree, 60 degree measurements. They have special properties as to how their side lengths relate. You do need to have these memorized and be able to use them to find other side lengths. So let's start looking at what these triangles are. The first one is called a 45, 45, 90. Okay, we just name it right after whatever the angle measurements are. So on this 45, 45, 90, this is what we'd call kind of a model or a unit triangle for this. Whatever our leg lengths are, and you'll notice that they are the same on a 45, 45, 90. If we know what those are, and let's just say they're 1, the hypotenuse is going to be times the square root of 2. So if our leg length is 1, we go times the square root of 2 and we can find our hypotenuse. Now we can expand this out to other leg lengths. For example, let's say that this leg length was 3. The hypotenuse would then be 3 times the square root of 2, or 3 times the square root of 2. That's the farthest we can simplify it. Conversely, maybe we know the hypotenuse and we want to find a leg length. Well, we can take whatever that hypotenuse is and work backwards. Instead of multiplying, we're going to divide by the square root of 2 to find that leg length. Okay? Again, that's just the very intuitive way. The intuitive way may work well for you. We'll look at a second example also when we get to the example problems. All right, our next one is called a 30, 60, 90. Okay? This would have the other two angle measurements that are very common in engineering and construction, things like that. On the 30, 60, 90, the shortest length, if it has a measure of 1, the hypotenuse is going to be twice that. So if we know our shortest leg, we can take it times 2 and find our hypotenuse. Example, if this was 10, the hypotenuse is going to measure 20. Also, if we know the short side, the long leg is going to be whatever the short leg is times the square root of 3. Okay? Same concept as here, though. We can also work backwards. If we know the long leg, we can divide by the square root of 3 to find our short leg. If we know our hypotenuse, we can divide by 2 to find our short leg. And one thing to watch here going forward, a couple things actually. Remember that even, let's just say I didn't have this angle measurement labeled, it's obviously still a 45, 45, 90 by our angle sum theorem, okay? That would have to be 45 even if it's not labeled. Same concept here. As long as we got either the 30 or the 60 labeled, it's a 30, 60, 90. We don't have to have every one of them labeled because of our angle sum theory. Another thing to be kind of watching here, when it comes to solving these triangles, there isn't a good direct relationship between the longest leg and the hypotenuse. In fact, what is usually easiest is, if take the one you know, find the shortest leg, and use the shortest leg to find whichever one is not working. All right, let's look at a few examples here. All right, and we're going to start with our 45, 45, 90s. We're going to do a first example doing it intuitively, and then I'm also going to show you using our similar triangle concept that can help us here. So if on this triangle we know a leg length of 4, we want to find the hypotenuse, which we've called x. Well, if we think back to what that triangle looks like, the 45, 45, 90, 1, 1, square root of 2. Okay? Put 45 in there. Really, really small. So, if we know a leg length of 4, to find the hypotenuse, we take our leg length times the square root of 2. So, x is going to equal 4 times the square root of 2. And we're done. That's the furthest we can simplify our radicals. Now, that works great intuitively. For some of you, that might be a little bit harder. So, let's look at another strategy to do this. Remember that since we know we have a 90 and a 45, and another 90 and a 45, these two triangles are similar by the angle-angle similarity theorem. So that means their side lengths are going to be proportional. We can set up a proportion to be able to solve this. So let's compare these sides. If this side is 4, that compares to the side here of our model triangle that is 1. We want to find our hypotenuse. That side on the model triangle is the square root of 2. Cross multiply and solve. 1 times x is x. 4 times the square root of 2 is 4 times the square root of 2. We get the same answer both ways. This way may seem a little faster, but if you can set it up correctly, this way may be a little more accurate. And especially if you're struggling to see this intuitively, this is going to be a better option for you at the beginning until you can maybe just see these relationships happening. Let's look at another. Again, we'll first go intuitively. Our hypotenuse is 18. We want to find our leg length, which is x. So, to go back, we'll do 18. We're going to divide by the square root of 2. So, x is going to equal 18 divided by the square root of 2. Now remember, we cannot leave radicals in the denominator. That's just a rule of math. We can't get around it. And if it's wanting your answer in simplest radical form, which is what we're doing here, we're not computing the radical and giving it to you as a decimal. Some problems may want it as a decimal. You've got to read the instructions carefully. So we need to do what's called rationalizing the denominator. So we're going to take both the top and the bottom times the denominator. Okay? Just like that. All right. Square root of 2 times the square root of 2. Well, inside the radicals, we just multiply those. 2 times 2 is 4. Square root of 4 is 2. All right? And remember that if we take the square root of number times the square root of the same number, the answer is just going to be the number. Okay? Our top will be 18 times the square root of 2. We can't simplify anything there. We're not quite done. After you get this far, look at the numbers that are outside of that radical. Notice that we could factor out and simplify just like we would a fraction. 2 divided by 2 is 1. 18 divided by 2 is 9. So we're left with 9 times the square root of 2. All right, again, that's kind of doing it intuitively. Let's look at it like we're setting up similar triangles. So 18 is the hypotenuse on the triangle that we're trying to solve for. We compare that to what the hypotenuse is on our model triangle. Square root of 2 is going to equal, we're trying to find x, and that compares to a leg length of 1. Okay? Let's do this side first. Square root of 2 times x is x times the square root of 2 equals 1 times 18, which is just 18. Now, to get the x by itself, this is multiplying, so we're going to divide. We're going to get x equals 18 divided by the square root of 2. Now, we still need to rationalize the denominator here, but you've already seen me do that up here. It'd be the same process. We're going to get the same answer of 9 times the square root of 2. Okay? Let's look at 30, 60, 90s. Again, I have not went through and labeled every angle, but because this angle is 60, this one has to be 90. Let's solve this for both x and y. And I'm going to draw in a little model triangle again. It does help to draw these several times. It will help you memorize them. So we got a 60, a 30, so we've got 1, square root of 3, and 2. Drawing them out several times will help you to memorize them. I do expect you to know these. All right. Usually in these type of problems, if you're not given it, the easiest one to find first is the shortest length. Okay, the shortest length is going to be opposite the 30-degree angle. So, remember from our model triangle, thinking intuitively first, the shortest length times 2 is going to give us the hypotenuse. Working backwards, the hypotenuse divided by 2 is going to give us the shortest length. So 10 divided by 2 tells us that x is equal to 5. Now, once we have the short length, the longer length is usually a little easier to find. Looking at our model here, the shortest length times the square root of 3 is going to give us our long length. So y is going to be whatever the short length is, which is 5, times the square root of 3. Okay? And we can't simplify there any further. Again, that works great if you work it intuitively. Let's work it one time here using some proportions. Let's set back up to find x. X corresponds to the side length of 1 in our model triangle. We take something we know, which is 10. On this, that corresponds to the hypotenuse of 2. Cross multiply and solve. We get 2x equals 10, and we see that x equals 5. We can set the same thing up here for our y. Okay, we don't know our y. That corresponds to the square root of 3 on our model triangle. And we can start, really, the one beauty about this method is you wouldn't have to find the shortest one first, but I still think it's easier. Our x here was 5, and on our model triangle it was 1. So, cross multiply. 1 times y is y. 5 times the square root of 3 gives us our y. Same answers. All right. This one I'm going to work out and just do intuitively. I think you've seen enough examples here of setting up the proportions that this should work pretty well. In this case, I'm given the long leg first, and I need to find the short leg and the hypotenuse. There isn't a good direct relationship between these two. There is one, but it's a little harder to remember. So I always like to take the long leg and find the short leg first. So let's do, that's going to be 12 divided by the square root of 3. That's what x is going to be. Rationalize our denominator. Gives us 12 times the square root of 3 over 3. Factor out of 4. Divide both the top and bottom by 3, so we factor out of 3. Tells us x is 4 times the square root of 3. Let's find y. Y is going to be the short length times 2, so we're just going to take 4 times the square root of 3 times 2. So, to take that times 2, we just take 2 times 4, we get y equals 8 times the square root of 3.